Hey guys, welcome back. I hope you enjoyed your Thanksgiving break. So after today, we only have two more assignments, three, including today's assignment. So we're almost there. Then we'll take the practice test on Friday, and then we'll do our actual test on Monday. So I'll post or probably Tuesday. I'll post a solution video to the practice test on Monday, and then on Tuesday, you guys can start taking the last test. Then you'll have the remaining 2 weeks or 1.5 weeks or whatever just to work on getting caught up on homework. Currently, right now, your homework is worth half of your grade and the test scores are the other half of your grade. If we're not able to go back to school for the last 2 weeks, so I can do the remediation that we need to do to redo our retakes, then I'll probably end up weighting the homework worth even more. I'm not sure how much more, maybe 60% of the grade or maybe 70% of the grade, meaning if you turned in all of your homework, you'd have at least a C, a 70% in the class, okay? So either way, it's in your best interest to make sure you've turned in all of your homework, because that's something that you can do even when you're at home. So we'll have the whole remainder of the time to be able to get our grades up. So please make sure that you do turn in any assignments that are incomplete or that are missing. You can turn them in for full credit. Please just get them into me and I'll get them graded for you. Okay. All right. So we learned with congruent triangles or any congruent figures that all the corresponding sides are congruent and all the corresponding angles are congruent as well. And we can show all those sides and angles by writing a congruency statement. So we say triangle ABC is congruent to triangle DEF, meaning triangle or angle A, which is the first one, has to be congruent to angle D, which is the first one on our congruency statement. Angle B, which is 90 degrees, has to be congruent to angle E, which is 90 degrees. And the last one, C, 53, has to be congruent to F, which is 53. So what we're showing here is that all corresponding angles have to be congruent. Then the other part is the corresponding sides. So the side AB, the first two goes with DE. So if AB is 8, then DE is also going to be 8. If the last two BC is 6, then the last two EF is also going to be 6. And then the first and last AC is 10, so the DF first and last is going to be 10 as well. So we notice all the corresponding angles are congruent and all the corresponding sides are congruent as well. Now, we were able to also use that to prove that triangles were congruent by showing that all the sides and all the angles, the corresponding parts, were congruent. And that would be how we prove that the figures were indeed congruent. And then the second lesson, we learned that if we know that all the sides are congruent on a triangle, by side, 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 those triangles must be congruent. So if we know all the sides are the same, that's enough information to prove that they have to be the same triangle, even though we don't know anything about their angles, which is kind of cool. We also learned side included angle side, meaning if I know that we have side of 6 included angle of 53 and other side of 10 is the same as this 6, 53, included 53 by the way, and 10, then that would be enough to show that they were congruent as well. We could also do 8, 37, and 10, 8, 37, and 10, either way, right? So side included angle side and side, side, side were two of our first congruency statements. Now we have two more congruency statements, really technically three, or postulates, I should say, postulates, congruency postulates that we'll be able to. So we'll have 5 altogether. Today we're going to talk about 2 more, then we'll leave the last one for tomorrow. All right, so we looked at, what about angles? So if we know all the sides are the same, that's side, 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 that works. What if we only know all the angles are the same? Well, in our diagram here, which is kind of cool, because of the parallel lines, the alternate interior angles are congruent, meaning this angle here is the same as this angle down here, and these two vertical angles, of course, have to be the same as well. And if we know that 2 of the angles are the same, like we know the vertical angles here, they have to be the same because vertical angles are congruent, and both of these are right angles, then means the third angles here had to be the same as well anyway. So that's by the third angles theorem, which again is pretty important. Don't forget that because we're going to have stuff like that on the proofs. Okay, so once we know that the angles are all the same, are these triangles are congruent? Well, no, they have the same shape, right? They're both the same right triangle, which comes from the corresponding angle. So they are similar to each other, but they're not congruent because they don't have the same size. So we know at all times, even if I move this over here, the vertical angles never change. The alternate interior angles never change. There's still going to be similar triangles because they have the same angles, but they're not going to be congruent triangles. The only time they're congruent is when we know one of the sides. If we know all the angles are the same, they're similar, but we have to know one of the corresponding sides has to be the same, then we know that they are going to be congruent. So for instance, the moment I tell you that this side and this side are congruent, meaning this is a midpoint, then we can prove that they're going to be congruent triangles by angle, side, angle, right? Vertical angle, side, right angle. vertical angle, side, right angle. So that's ASA. Let me write it out here. So we have angle, side, angle. So we have angle, included side, angle. So that would be ASA, where the side, this is what's special about the side? Well, the side is included in between the two angles. All right, so we could also do this with, let me change colors real quick. So if I told you this side here is the same side length as this one here. Now let's forget this one and forget this side here. So now we have, get rid of the S as well. Now we have angle, angle, side, okay? Angle, angle, side. Well, notice this one's different because the side is not included in between the angles anymore. Now it's after it. So this is going to be angle, angle, side congruency postulate. Okay, notice that the side is not in between the two angles like it was on this one. So this works as well, right? So we can either have angle, side, angle, or angle, angle, side, and that would be enough information to prove that these triangles are indeed congruent to each other. So far we have side, 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 which is when all the sides are the same. And then we have side, angle, side, and then the ones we learned today are angle, angle, side, and angle, side, angle. We also notice that angle, angle, which is the same thing also as angle, angle, angle. Because if you think about it, if you know two of the angles, we know the third angle has to be the same as well. So angle, angle is really the same thing as angle, angle, angle. These do not work because they simply show that the triangles are similar, meaning they have the same shape, but are not necessarily the same size. They're only going to be congruent once it passes through this midpoint, and one of the sides, corresponding sides, is going to be congruent to the other one. Then we can use ASA if it's an included side between the two angles, or angle, angle, side. All right, cool stuff, good stuff. Moving on. So what about angle, angle in the third angles theorem? Let's say I tell you that we have a triangle and the angles are 40 and 50. And I draw another triangle over here with angles of 40 and 50. Are these two triangles, are they congruent to each other? So if I move this one over here, are they necessarily going to be exactly the same size? No, they're the same shape, but not necessarily the same size. Now, the reason for this is that when we have all the angles, the triangle's still allowed, it has a degree of freedom where it's allowed to get larger or smaller. So this part here, this 50-degree angle, could be smaller or it could be further out, right? And they still have the same three angles, but they're not going to be congruent. They're only going to be congruent when they exactly have one of the sides that are the same. So that would be at this point, like right here. And that would be the same when we know one of the sides. So for instance, if I told you the base is 10, and this one also has a base of 10, then by angle, okay, we have angle, included side, angle. So ASA, I'm sure you can't see that because it's where my face is at. So boom, let me move it over here. So by angle, included side, angle, these two would be congruent. Now, if I told you instead that this side here was 12, so we have 10 and 12, they're no longer congruent, meaning this angle is, or this side length is further out, and so they're not going to be the same size. They are going to be the same shape though. So we would say in that case that they were similar to each other, meaning they had the same shape from angle, angle, but they're not going to be congruent because they're not equal size, because their sides were not the same. They're a proportion, but they're not the same. All right, so the other one we have is angle, side, angle. So for instance, on this one, I was going to do something, but I decided I didn't have time. So let me put it back here. So I give you this angle A, the side length of 8, and the side down angle here of 53. So angle, included side, angle, angle, included side, angle. They match up. So if they're the same, it means the triangles are congruent. But as soon as it was not, so let's say this is actually smaller. I guess I can move it down here to make it smaller. Okay. Now that this is no longer 8, but this, let's say, is 6, now they're no longer going to be congruent. Let me go back to where we were. All right, so the other thing we have is a third angles postulate. So if I know two of the angles, I know the missing angle has to be 72 because they have to add up to 180. So this one has to be 72 as well, which means I could actually, instead of using the angle, side, angle postulate, I could also use angle, angle, side, where the side is not included in between them. So this is the third angles theorem, really. So if I know two of the angles are congruent, then I know the third angle is congruent as well. So we have angle, angle, side, just as we could use angle, side, angle. So anytime we can use one of them, we could use the other one as well. And the reason for that is the third angles theorem. So we could either use angle, side, angle, or because the third angles are congruent as well, angle, angle, side. All right, so let's use our example here. What do we know? Well, these two angles are the same. They have the same marking here. If this is a right angle, the other part has to be a right angle. And then the reflexive property. Remember the creepy baby, things are congruent to themselves. So AB is congruent. It's the same AB for this side of the triangle as it is for this side of the triangle. So for triangle 1 as it is for triangle 2. So what postulate are we using? Well, we have, let me change colors real quick. Let's use red. We have this angle, we have this included side, and this angle down here, right? The same angle up here, the same included side, and the same angle down here. So it's going to be ASA. So triangle ABC is congruent to triangle ABD by angle, side, angle congruency postulate, where the important part of the side is that it's going to be included in between the two angles. This is not angle, angle, side. This is angle, side, angle. Now, in case you're wondering, not to confuse you, but we do know that the third angles are the same as well. This is an extra step, so it's not how you do it on the homework, but you could also use angle, angle, side because of the third angles theorem. But that's an extra step. It's not the most direct solution, so don't worry about that. All right, example 2. So on this one, we have parallel lines, which is good. So alternate interior angles are going to be congruent. So for instance, angle A is going to be congruent to angle E. Okay, alternate interior. And then also vertical angles in the middle are the same. And then they also mark this as congruent to this one, which is good. So we have, in this case, let me change colors again. We have angle, included side, angle. Then we have the same angle down here, included side, angle. So this is going to be triangle ABC is congruent to triangle EBD by angle, included side, angle. And again, the importance is the locations, the side, which is directly in between the two congruent angles, or corresponding congruent angles. You get what I'm saying. All right, the other one we have is angle, angle, side. So if I was graphing this one out, and I had 30, 80, and then this blue line here. So if I draw another 30 and 80 degree line, I know that they actually have to be congruent if the blue line is the same length. So let's say that it was, if we drew it out too far out, well, we could actually bring it in here. There's a really fun activity we do in class with the compasses and stuff. I was really bummed that we weren't going to be able to do it because we didn't get to go back to school this week. But maybe if we finish everything early the second semester, if let's like assume that we're back in person, we can go back and do all of our fun compass work. Like there's an entire unit 6 that we're having to skip because it's all compass work. It really kind of bums me out, but hopefully we'll be more efficient next semester. We kind of got into the groove of things, and we'll be able to do more of our in-person activities and fun games and stuff like that. You know, all the things that make you want to go to school and enjoy my class. We'll be able to do those in class, so I want to do them. Anyway, we can move it in here. We still have the same angle, 80 degrees, 80 degrees. We move it in. We would connect the dots between those two, and then somewhere between those would be this line here, which would be where they would have to be congruent. Now we have the same angle, 30, 80, and then the length of the blue line now meets up here. And if we moved it over, sure enough, it would be exactly the same as the ABC that it had on this side over here, which is really, really cool. And would have been cooler if we could have done the activity in class, but it's okay. Don't worry about it. All right, so the example we have here, we have a right angle, right angle. We have the same angle here as we do here. Looks like alternate interior, which means you could actually say that these lines are parallel, but that's not necessary. And then BD is going to be congruent to itself by the reflexive property, right? So in this case, let me change colors. We have angle, angle, side. So if you notice the importance, the side is not the one directly or included in between the two angles. It's going to be angle, angle, side in this case, where the side is after the two angles. So angle, angle, side. It's kind of like we're curving, going all the way around. Not angle, side, angle. That would be if this side was congruent to that side. It's angle, angle, side. And the same thing over here, angle, angle, side, AAS. Okay? All right, so congruency versus similar. Let's say that we had an equilateral triangle. And then I drew another equilateral triangle. Whoa, that was fun. Magic. Now, both of these are similar because they have the same... Oh, no. Okay, so now both of these are similar because they have the same shape, right? They have the same angles, 60 degrees all the way around. But this is angle-angle similarity postulate, not congruency. Okay, there is no angle-angle congruency postulate. Now, in order for me to say that these two triangles are not just the same shape, but the same size as well, I need to know what one of the sides are here. So if I knew that this side here, if it was 4, well, that matches up with this 4. Then by angle, side angle, they would have to be congruent. But it doesn't look like it's 4. It's probably more like 14. And now they know it's 14. Well, clearly they're not the same size. So they're the same shape, but not the same size. So what we actually have here is just similarity. These triangles are similar to each other, not necessarily congruent, unless I knew that one of their corresponding sides, lengths, were exactly the same. Then we could use angle, side angle, or angle, angle, side. All right, so the third angles theorem here, if I know we have 75 and 50, the missing angle has to be 55. So same thing, 75 and 50's missing one have to be 55 here. Now, these two triangles are similar at this point. The only thing I'm missing is to know one of the sides. So angle, angle does not work because it's still allowed to grow. It's got a degree of freedom there, or shrink. But if I told you that the angle that's in between, let's say the smallest side here is 6, and the smallest side over here is also 6, then that forces it to kind of fill. You can kind of see the red matching up there, where those two would have to shrink down to be congruent. Now they're no longer similar, but they're actually congruent. Okay, now if it was the wrong location, so if the longest side over here was 6 and the shortest one over here was 6, they don't work because they're not aligning up between the right angles, right? So 56, 50, 55, 6, 75, no, it doesn't match up. So they have to be in the same location, and then that will make them congruent. All right, so let's go ahead and start the assignment here. 1 through 3, MG and T in our triangle. What angle is included between GM and MT? Now, if you remember, that's going to be the one that's repeated. But if we look at here, GM and MT, the angle included between those two is going to be angle M. So our answer would be angle M. Looks like a C. Should be a sharper angle. Which sides include T? So T is included by sides MT and GT. Okay, so MT and GT would include this angle T. What angle is included between GT and MG? So GT and MG would be angle G. So that would be angle G. All right, two triangles have the following pairs of congruent sides given there. Okay, write a congruency statement for the two triangles. So BD is the first two, so I'm going to line that one up with FJ. Then DG, which is the last two, I'm going to line that up with JM, the last two. And then GB, last and first, goes with MF, last and first. So we know we got it. There would be our congruency statement. Given QRS is congruent, so we have the congruency statement. Again, packed in all of that is all the information we need for all 6 corresponding parts that are all going to be congruent. Name an angular side that corresponds with each one. So Q, the first one, is going to go with angle T, the first one. RS, the last two, goes with the last two UV. Okay. Angle S, the last angle, goes with the last one, angle V. And then QS, the first and last, goes with side TV, the first and last, on the other part of the congruency statement. So easy stuff. Name the two triangles that are congruent by angle, side angle. So if we look over here, all right, this one only has angles, so that can't be anything because we have to have a side, right? Otherwise, they're just similar. So over here we have an angle of 1, a side of 1, and an angle of 2. Then here we have an angle of 1, a side of 1, and an angle of 2. So if you see those, they're flipped, but that does give us enough information just from looking at these parts here and these parts here to say that those two triangles are going to be congruent. Now we didn't need this extra information here, and there was none given on these two, so that's totally fine. So write the congruency statement. So we're going to say KLM. So triangle KLM is congruent to triangle what? Well, K is angle 1. That goes with J, which is angle 1. And then L is angle 2, which goes with I. So then the last one is JI. And of course, it has to be H. Okay, cool. So no big deal. And again, we did that by angle, side, angle. All right, given B and D are right angles, so that's already given. And AE bisects BD, means it cuts in half. So AE cuts this one in half. All right, so the first part is that BC and CD are the same. Now, if AE cuts it in half, that means that those two segments are congruent. Now, that's going to be by the definition. So definition, again, that's how I do it. It's kind of weird. Definition of bisect. That should be a B. Okay. And the next part is the angle C's, which are the ones in the middle, are going to be congruent. Now, we know the angles in the middle are congruent because they are vertical. Okay. and then the triangles are congruent. Now, our final congruency statement comes from one of our congruency postulates. Now, in this case, we have angle included side angle, angle included side angle. So that's going to be ASA, angle side angle, where the side is in between the two angles. Okay. Now, if I told you this side and this side, then it would be angle angle side. But no, the side is in between the two angles, so it's angle side angle. All right, given the angles are congruent and AB is perpendicular, which means that that's a right angle. KL is perpendicular, that's a right angle. And AB is congruent to KL. So we're going to mark it as we go. All right, first thing, AB is congruent to KL. Oh, that was given to us, so that's given. I'm going to go ahead and mark that. So AB and KL are congruent. Just mark it. Then these two are right angles. That was by definition of perpendicular. So definition of perpendicular. You can use a symbol if you want. That'll save you time. So definition of perpendicular. And then the last thing they said, the triangles are congruent. By what postulate? Well, if we look here, we have angle, angle, and a side. Now, is this angle, angle, side, or is it angle, side, angle? So the question we need to ask ourselves is the side located in between the two angles, included between the two angles, included, or is it after the two angles? So in this case, the side that would be in between it would be if it was angle, side, angle. But we don't know this side length. The side is after it. So it would be angle, angle, side. So this is going to be by angle, angle, side. So angle, angle, side, angle, angle, side. Good to go. 21. JM bisects angle J. So JM cuts this angle in half. So that angle and that angle are the same. So angle KJM and LJM are congruent. This is going to be by the definition of bisect. And then hey Google, never mind. No, I don't want to know how to spell bisect. I already know. Okay, thanks Google. So helpful. Don't use Google when you're taking your test, please. All right, so JM is congruent to itself. That's by the reflexive property. I hope you guys could hear my Google Assistant talking. Otherwise, I was just talking to myself. But and then the triangles are congruent by what postulate? So that would be, that's a right angle. So in this case, we've got angle, side, angle, right? So again, the side this time is going to be in between the two angles. So this is going to be angle, side, angle. All right. Almost done? Nope, still going. Well, we're only 22 minutes in. 24, state the postulate or theorem you would use to prove the triangles congruent. So if the triangles can't be congruent, then just write non-information. So on this one, we have sides are the same, these sides are the same, and the angle in the middle is the same. So is this going to be angle, side, angle? Think about it. What did we do wrong? All right, well, the sides are the same on the same triangle. These sides are the same on this triangle, but they're not the same across the triangles, okay? So if we change this so that this one was 2 and that was 2, and this one was 3 and this one was 3, now it would be true. Because the 2 would go with the 2, 1 would go with the 1, and the 3 goes with 3. But the way it is currently, it's not right? So these two don't have to be the same. These two don't have to be the same. They have to be the same going across. So be careful there. So our answer to this one is actually not enough. Or we can just say, well, it's just not enough. They could be congruent, but yeah, we'll say not enough information. How about that? All right, 26. Looks like I was doctoring up this image and I never finished because I want it to look pretty, like that one. All right, so on this one, we have the sides are the same, these angles are the same, and then we know reflexive BC is congruent to itself. So are they congruent? Well, we have angle. This angle is the same, right? That is not an angle. Wow, I am apparently tired and need to go to bed. Okay, so we have side, side. That angle is the same as that one, and this side is the same as that side for both triangles. So we have side, angle, side, side, angle, side. Well, I should say in the same order. So side, angle, side, side, angle, side. There we go. So yes, and our answer would just be side, angle, side. 34, same thing. On this one, we have angle, side, side, angle, side, side. So these two are actually going to be using the donkey postulate. If you remember that one, So we don't use that word in class. So a money sign, money sign. I don't know what it means. Again, so many inside jokes, really funny. I know you're surprised that I wrote that word. So controversial. It's not the worst thing I've done all year. Let's be honest. I've done worse things. Anyway, so angle side side donkey postulate does not work. Okay, and the reason it doesn't work is actually shown really well here. It's ambiguous. So this side length here is actually allowed to it's allowed to swing, which we would actually show this in class using our compass. Swinging the compass would be really nice. But notice they have the same angle, the same side length, the same side length, angle side side, as this one, angle side side. But on this one of them is an obtuse triangle and the other one is just merely an acute triangle, but they still have the same angle side side. That's why the donkey postulate does not work unless we have a right angle, and then it's called the hypotenuse leg theorem. But you'll learn that in about 2 days, so just hang on tight or loosely. Don't let go. All right, that's it. So right around 25 minutes. This sounds good to me. Let me know if you have any questions. We've got 2 more assignments after today's. So we're going to be done with this stuff pretty quick. Make sure you're staying caught up with your homework. Again, we've got 3 weeks, including this week, in order to get all of your homework turned in. If you have any homework that's incomplete or that has not been done, make sure you turn it in because that will help bring your grades up. Yeah, I'll see you guys later. Have a good